Hello, everyone, and welcome back to a new session, Computer Science 2 at LTU for summer 2022. Today, we are at week June 27th. We're going to go over chapter 16, which is exceptions and templates. Exceptions are not specifically related to templates. They are two different topics. They can relate to each other, just like all other topics can relate to each other. But for some reason, the book has them in the same chapter. So we're going to go over exceptions, then we're going to go over templates. Just a quick reminder that homework 6 has been assigned and it's due Sunday midnight. Also, project 3 is due Sunday midnight. With that being said, I have the book as usual in front of me and it's on page 989, which is chapter 16, and says exceptions and templates. I have my empty program here that we're going to use to start. So before we start with the coding and the syntax, let's do some definitions and some info, some knowledge. Let's define what are exceptions. So exceptions, what are exceptions? Exceptions are used in order to signal errors or unexpected behavior or events that may occur while the program is running, and pay attention to is running. That means it's only for runtime errors. Anytime you have a runtime error in C++, the whole program crashes. It's not like some other programming language where if you have an error within this scope, then only this scope fails and the rest of the program continues executing. No, in C++, it's not the case. In C++, wherever you have an error, the whole system or the whole program will come to a halt, will come to an end, and you can't continue anymore. For example, dividing by 0 is a runtime error. Let's say I have two integers, al first, al second. Then I'm going to ask the user, enter first, cin into al first. Then cout, enter second, cin into al second. Then I'm going to say, okay, int x or int result equal al first over al second. So let's say here, for example, the rest of the program. So I'm attempting to divide here, and then I have statements or other statements after that operator or after that division task. So let's say I enter 0, I enter 1, and then I enter 0. Notice when I enter 0, it's going to pop up a message, basically an error, on this line, and it's going to tell me exception unhandled. Unhandled exception at blah, 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 integer division by 0. So this exception that was thrown, this has been thrown. This exception that has been thrown was unhandled, and that's why I can no longer continue. There is no way I can continue my program because there was a runtime error during while the program is running, and it's an exception and it was unhandled. So this topic here is a way to handle exceptions, to handle runtime errors. No matter what are the runtime errors, I can handle them and then I can continue with the rest of my program. Right now, I can't continue. I can't reach the rest of my program. So the key words that you need to know about are try, throw, catch. These are this is like the flow of your code once you are introduced to exceptions or once you use exception handling. You're gonna have a code for trying And if that code fails, you're gonna throw an exception, and then you're gonna catch that exception and handle it. Finally, continue. Continue with the rest of your program. So this is the flow of your logic. So back to this program, let's start with the first one. So I know for this humble example, I know that this is the problematic statement. So I'm gonna use only this line of code, just so we have it simple and in front of us. I'm not gonna use the above, I'm not gonna use the below, I'm just gonna focus on this line because I know that this line is where the exception is being thrown. So I'm gonna add the code try, then I'm gonna open curly braces, I'm gonna close curly braces, then I'm gonna have a catch statement, open parentheses, just like functions. This open parentheses require an input, and it requires a scope as well. So what is my input here? My input here is whatever I'm gonna throw. If I'm gonna throw a string, then this catch statement should receive a string. If I throw an integer, then this catch statement should receive an integer. As a matter of fact, I can overload this catch, meaning I can have one for string, one for integer, one for character, for example. So now I'm going to say, okay, this one receives a string exception. This one receives an int exception. This one receives a char exception. So now that these are in place, I'm going to say, okay, see out whatever the parameter is because it's a string. This, for example, is going to say, so since it's an error, so let's treat it as an error code. Just like web browsing, when there is a page not found, you see the code is 404. So it's going to say error code 404 page not found. So here I'm going to say error code, for example, whatever the error I receive. Here, same. For example, I'm going to say error char, whatever char I receive. So these catch are in place. Then the rest of my program. Here I might have a lot of tasks, not just one statement. The rest of my program, whatever the rest of my program is. So I'm still missing one thing, which is the throw piece. So here, before I attempt to try this code, I'm gonna say if second equals to 0, throw. First, we're gonna try the string, local string exception. Then I'm gonna define it, string, for example, lstr exception equals can't divide by 0. So I have a string ready, and in case second is equals to 0, I'm gonna throw this string. Otherwise, I'm just gonna divide. So let's run this program using the F10. I'm gonna skip these all the way to here. Continue. So 1, 2. So is second equals to 0? No. Then okay, attempt, just do the division. Result is whatever, and I move on with the rest of my program. Nothing bad happens. Nothing, no runtime error. I'm gonna start over. I'm gonna start again, and then I'm gonna now say, okay, 0. Now that second is 0, notice I reach this statement. This statement is similar to the return, meaning once this throw is called, nothing after throw will be executed. Everything after throw will be ignored. Throw will throw my control. Notice my control is right here, right now. Throw will throw this control to the catch block based on which type I'm passing it. Just like function overloading. If you call the function, let's say you have the same function name with the 3 versions. One version is with string, one version is with integer, one version is with character. If you call the function with a string parameter, then the version for string will be executed. If you call the function with an integer data type, then the integer version will be executed. So here it's same, it's similar logic, same logic. If I'm throwing a string, then the version that receives a string will be executed. So notice I'm gonna put a breakpoint here, and a breakpoint in my string version. And when I hit continue, or I'm gonna use F10 actually, notice my control is going to go to the string version and it will ignore all the other versions. So F10, notice it's here right now, and string exception is the parameter that I receive. Can't divide by 0. So I'm going to display it on the screen. Then I'm going to continue with F10 with the rest of my program. Notice before, if you realize, before using try catch, I wasn't able to reach the rest of my program. I wasn't able to continue because once a runtime error occurs or is thrown, the whole program will come to a halt. So here, can divide by 0, then the rest of my program executes fine. Let's try, for example, with an integer this time. I'm going to say int a l int exception. I'm gonna say it is 404, for example. Well, 40 whatever, because it's not page not found. And this time I'm gonna throw an integer instead of a string. So I'm gonna execute. I'm gonna say 1 0. Then I'm gonna hit the throw statement. It's gonna throw 403, which is an integer. Notice this time it didn't execute the string version, it executed the integer version, and it's gonna say error code, whatever, and it will continue with my program. So error code 403 and the rest of my program. Let's actually change this font. Let's do it like this. Maybe this is much better. Font 28. Yep. So first, second, error code 403, and then the rest of my program. Let's do it one more time with the character. L char exception. I'm gonna say then I'm gonna throw this character and I'm gonna run again. So 1 0, I reach the throw statement, I continue. Now notice the version for character has been executed and integer was ignored, string was ignored, and I can continue with my code. So character code is O, and then the rest of my program. So that's the basic idea and the basic syntax for exceptions. It's a way to handle runtime errors and in a way that I, as a developer, can manage it. For example, let's say here I'm doing network streaming. When something happens with my network streaming in the catch block, for example, I want to shut down the network. I want to disconnect. I want to shut down the antenna. I can handle the error that occurred instead of just keeping everything open, keeping everything locked, keeping everything being used. In this block, I can do whatever I want. I can handle that exception, and then I can continue. For example, in continuing, I might ask the user for a new new value. For example, let's put everything cut. Let's put everything in a loop. So I'm gonna say do this while, for example, L second equals to 0. Semicolon. Then I'm gonna put the try inside my do while. So it's gonna try, it's gonna throw, and then it will continue. It will continue executing. So in this case, I'm gonna start with this, and then if it is 0, it's gonna throw error code, da da da. Let's throw, for example, string L str exception equals can't divide by 0. And I'm gonna throw this string. So just for this example, I'm gonna remove these two because I'm not using them. Second, what is this? Second is undefined. It is defined. Do while oh, it has to be out the scope so that while sees it. So now I'm gonna try. Here you go. Go. 1 0 can divide by 0. Repeat. 1 0 1 0 1 2. Now the rest of my program. So I was able to handle runtime error instead of crashing the program. And I handled it by basically displaying an error message to the user and repeating. So let me remove this now. Cout is ambiguous. IOStream, std, build. Now it's not ambiguous anymore. Interesting. Okay. Visual Studio maybe needs to be restarted. Sometimes it misbehaves. It's telling me that Cout is ambiguous, but it's not. And the program builds fine. Okay, here we go. So back to the book from page 989, exceptions. It's defining an exception, and then it's showing you how try, catch blocks are structured, which what we see here. Try, the keyword try, scope, then the keyword catch, parentheses like functions, and then another scope for the catch block. Then they try to show you how to throw an exception. Then on the following page, it's informing you what if an exception is not code. So in case an exception is not code, just like we saw earlier, in case an exception is thrown and it's not handled or it's not code, then the system will crash or basically will come to a halt. Then they start introducing object-oriented exception handling, which we're gonna do a quick example. So let's say I have a class. I have a class called rectangle. This rectangle has, I'm gonna do them as public for now. This rectangle has, of course, it has a constructor. It has, let's do m width, m height. So m as integers, int. It has a constructor And then it has, for example, set width. So void set width. It takes an int a width and it sets width. Then I have set height, int a height, and I'm gonna keep it like this for now. So in set width, of course, width of anything cannot be negative. It's either 0 or above. So here I'm gonna say if a width, if the parameter, if a width, if the parameter is less than 0, then I would like to throw a string. So I'm gonna throw string object, and that string object will say can't, width is negative, width is negative. Now that I throw in the otherwise, I'm gonna say m width equals to a width. So once this statement is reached, this statement will not execute. This will be ignored because this throw behaves like return. It will skip everything else in this scope. I'm gonna do the same in set height. So I'm gonna say if height is negative, then throw. Otherwise, height equals a height. So I'm gonna go back to here. I'm gonna keep these. Enter first as enter width, enter height. I'm gonna say L width, L height, then width, then height. Oh, we don't need this code. So now that I have height, I'm gonna have my rectangle. So rectangle, L rectangle. This is my instance. And now that I read from the user, I'm gonna try a code. I'm gonna try the code L rectangle set height. I'm gonna pass it L height. Or I'm gonna set width as well. In case that one of these two throws an exception, then it's gonna be caught or handled in this block. So let's see. Okay, so go, enter width. I'm gonna say 10. Then enter height. I'm gonna say -5. So now I'm in the try block. Set width or set height -5. So I'm gonna click F11. F11 is height negative? Yes. Okay, then throw the data type string with this value. Now that I threw, since this line through, notice L rectangle has junk. That means everything after the throw has been ignored. So once this has been thrown, this was ignored. And also once this was thrown, that means once this function threw, this also got ignored. So if this method throws an exception, everything after that throw statement will be ignored. So this has been ignored, meaning the rest of the function, and also the rest of the try block has been ignored. The fact that this threw, the rest of this method has been ignored. Also, the lines after this method has been ignored. And the string is going to say height is negative. I can't have height. The rest of my program. The rest of my program can be anything, maybe asking the user again for a new value. So this is object-oriented exception handling basics, basically 101. What else do you need to know here? For example, you remember how I said you can throw whatever data type you want? You can throw your own data type. You can define your own exception that has, for example, message in it, time in it, log file in it, and then you can throw that type. You can catch that type, and then you can use that type to extract info. For example, I have my class here, right? And I have my main. I'm gonna remove these definitions to have clearer code. Here, for example, I'm gonna say I want a struct. I'm gonna call it my exception. So my exception type. In this exception type, I have a string called mMessage. I can, for example, have int error code. I can have, I don't know, exception date time, exception log file, like write to a file, write to a file. I can have a lot of tasks or methods or responsibilities in this user-defined data type. User in this way is developer. So I have this struct data type. In my rectangle, instead of throwing a string, I can throw my data type. For example, I'm going to put block here. And then I'm going to say, I need my exception type, L exception. This L exception dot message equals width is negative. This L exception dot error code equals, I don't know, 404. Then I can throw this type. I mean variable. Now that I threw this type, I need to catch or handle that type. But let me first do the same in set height. Here I have a scope, another scope, exception height is negative. And then throw this. Now, if I run right now and I throw, this type, this exception type is not handled yet. So I'm gonna reach a halt. Notice. If I say width is -5 and this is 10, this type of exception is unhandled. So see, my exception type, well, it doesn't say here, but this data type is not handled, so I can't continue. It's a runtime error that was not caught properly, and it's not handled properly. I can't continue. So what I can do is I can go to main and I can say try this code and then catch my exception type, a exception. Now that I receive this data type, I can say I want to display its message. So now I'm extracting info from that exception. The exception is an object and I'm extracting message from it. For example, have you ever seen that error when you're like playing a game or running a software or whatever, and then something happens and it crashes, and then you get a dialogue on the screen in Windows that says, hey, an error has been occurred or whatever. Do you want to send a report or don't send? And then you click, for example, don't send because nobody has time for typing info and sending it. This dialogue that pops up, it popped up in the catch statement. So here in the catch statement, something occurred, there was a code running and something occurred, and then the catch trying to handle the exception. Inside the catch, I can say, okay, pop up that dialogue, right? Pop up a dialogue. display the error message, ask to send report or not to, ask to or not to send report, right? The users, if the user says send, then send. If send, send. If not, send, continue. Continue meaning do nothing, meaning continue with the rest of the program. Well, the program shut down. For here, if no send, I can say shut down. Shut down some stuff. Shut down some stuff, save data maybe, shut down, save, turn off, reset, etc. Here, if send, then send and shut down, save, turn off, reset, etc. So basically that pop-up dialog that you saw came from the catch statement. The catch statement is trying to handle an exception that has been thrown while the program is or was running. So back to my example, I threw my defined data type and I extracted info from my data type. Let's see it. -5, 10. Width is negative. Where did this width is negative come from? It came from exception.message. Where did I populate this message? I populated it in here. If height or width, if width is negative, then I prepared an object or an instance of that struct. I said the message is this, I said the error code is this, and then I threw it. Now that I threw it, I was able to handle it here, catch it, handle it, and then continue with the rest of my program. Here it is. So this is what the book at this point is trying to show you, object-oriented exception handling. Then we go to, so extracting data from exception class, page 1001. Then the topic is rethrowing an exception. You can rethrow an exception. For example, let's have it as, to keep it simple, I'm gonna remove one of these, right? I'm gonna just say we have height, we don't have a width, just to make the code simple. We're gonna have only, we said height. Okay, so this is height, this is height, this is height, this is height, this is height. I'm gonna break here, I'm gonna break here. Now I'm gonna go here, and then I'm gonna say, remove this. I'm gonna have a method called check height, or validate height, and I'm gonna pass it height. Now I'm gonna have try catch in this block. So try catch. I'm gonna catch my type, a exception. I'm gonna move these two here. Catch, I'm gonna say cout from set height, catch block and set height. But then I'm gonna rethrow. So this will throw that type. Then this will handle that thrown exception. I'm gonna do some task but I'm gonna rethrow the exception. So let's implement this validate height. I'm gonna implement it here. I'm gonna say it's a void validate height. It takes an int a height and does what? It does whatever I was doing earlier. If height is negative, then throw. Otherwise, do nothing. So height is negative, blah, 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 validate height. If it is negative, then prepare exception and throw it. Otherwise, no need to do anything. So if height is negative, this method under set height under rectangle, this method will throw. When this throws, then this will handle it or catch it. When this catches it, it's gonna do some internal stuff, whatever internal to that object, whatever specific to that object. It's gonna do something and then it's gonna rethrow. So this throw is basically a rethrow. Why it's rethrow? Because it's a throwing under catch, meaning this will never execute unless there is an exception thrown. So we're gonna have exception thrown, then it's gonna be caught here, then it's gonna be rethrown here, then this set height will throw here, and then finally we're gonna see it here. So let's run. Go, enter height. I'm gonna say -10. So set height, I'm gonna click F11. Validate height, I'm gonna click F11. Is height negative? Yes. Okay, prepare an exception and throw it. Now that this threw an exception, it's gonna be caught here. We're gonna do some task, then we're gonna rethrow the same exception. We're gonna rethrow the same exception. Now I can throw a new exception. I can create a new exception just like I created an instance here. I can give it a different sentence. I can give it different error code. I can do whatever I want. But the fact that I'm throwing under catch, it means I'm rethrowing. So throw. Now that I click F10, it's gonna go to back to main. This method threw an exception, so it's gonna be caught here. Exception has this message, this code, and maybe other stuff, and then the rest of my program. Stop. Re-throwing an exception. The last topic in here is it's showing you that there are primitive exceptions data types. Basically, let's say I have an integer pointer dynamically allocated. So I'm gonna say, actually, let's make it bigger. So I want it to be double. I'm gonna call it LPTR equals null for now. Null PTR. Then here I'm gonna say this LPTR that I have equals new double, for example, 99999. So I'm gonna do this once, then twice without releasing, maybe like 10 times, maybe more. And then the type I'm gonna catch is bad alloc, bad allocation. Then I'm gonna say, I can say my own string, for example, insufficient memory. I can have my own message, or I can have, for example, if this is called, if I give it a name, exception, then it's gonna have what's called what. So a exception what means the message. So now if I run, go once, twice, go. At some point, okay, so I have a lot of memory. But at some point, I'm gonna have, let's for example wrap it with a loop for int I equals 0, I less than million times. And on each iteration, I'm gonna allocate this big of an array without deleting it, without releasing. So at some point, I'm gonna have insufficient memory. Go, 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 go. Go, 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 go. See, it's taking from. I'm gonna try to kill it. Okay, so it's back. Insufficient memory. Here you go. Woohoo! Close call. Close it. Close it. Not responding. Get my memory back. Okay, go. 56 gigabytes the program used. So now I should get my memory back. See how it's decreasing. Nice. So at some point I reached insufficient memory and my computer even froze. So this is it for exceptions. Now we're gonna go for templates. Templates, I'm gonna remove all this code because we no longer need it. Save, save, save. Template is a very simple, basic topic. It's called function templates. Function templates basically are, or a function template, a single function template is a generic function. It basically can work with any data type that you pass to. Similar to function overloading. In function overloading, you're gonna have the same function name and then different parameters. If you call it with integer, then the version of integer will execute. If you call the function with an input of string, then the version that receives a string will execute. Now, when it comes to function templates, you write the function once and it will work with any data type. And it has a specific task. Basically, the programmer writes the specification of the function, like the blueprints, if you may say, of the function, and then the compiler will find all the calls for that function and then will substitute the code or the parameter list that the programmer defined with the data type that the function is being called with. When the compiler encounters a call to the function, it generates code to handle that specific data type used in that code. For example, let's say I have a function called display. So void display, this takes an integer. I'm gonna call it a input. Cout integer. Then I'm gonna overload this method with a string and one for char. So string a integer. I'm gonna call it string. And this is for character. I'm gonna call it character. So now in my display method, I'm gonna call it 3 times. I'm gonna call it once with a string, one with, or let me give it a different meaning, hello, one with integer, 1, and one with a character. And then I'm going to run my program with F10. Notice when I call the function with a string, then the string version will be executed. If I call my function with an integer, then the integer version will be executed. If I call my function with a character, then the character version will be executed. So this is function overloading. I can replace all those three methods with only one function template as long as the body is identical. Hold on. Excuse me. So right now the bodies are different. One says integer, one says string, one says character. In case I had the same body, for example, hello world. In case I had the same body in all three, then I can replace all these with one template. Then that template can be called with a string or integer or character. Let's stay on string. Integer. So this is integer. I'm going to collapse all. And then I'm going to show you how to write a template. For example, the syntax is you're going to specify that the following is a template. Then you're going to say class T. T for template or for type. Then you're going to say void display. This is the data type. So you're going to say void display this data type input, meaning this will be replaced by this, meaning whatever the function receives will be replaced here. If the function receives an integer, then it's an int a input. If the function, let me take this out, provide something of inheritance, none. Come on, go away. Okay. Go away. Go away. What is this? Provide sample template arguments for IntelliSense. I don't want to provide. Why you're forcing me? Close. Anyway, oh, it's gone. Okay. So if the function receives whatever T the function will receive will be replaced by this T. So if the function receives an int, then it becomes void display int a input. If the function receives a string, then it becomes a string a input. For example, I'm gonna say this is a template for sum. This sum is gonna receive T a input 1 and another T a input 2. And this function will return T. So if this function receives an integer or two integers in this case, then it's gonna become return an int, sum, int a input 1, int a input 2. If it receives a string, then it becomes string, sum, string input 1, string input 2. Here I can say return a input 1 plus a input 2, for example. So I'm telling it, whatever T you receive, return the sum of them. You're going to receive two T's, then return the sum of them. If you receive two integers, then you're going to return one integer. If you receive two doubles, then you're going to say return one double. And at the same case, just so you know everything at this point, I don't have to be specific. I can say you're going to receive anything and I need you to return an integer. Now, if this fails, it's a runtime or it's a compilation error. When I click compile and for some reason this cannot be evaluated to integer, for example, to strings, If I receive two strings and I'm trying to return an integer, it will not work. Then the compiler is gonna say, hey, you're trying to cover more cases that the program can handle. You can't receive two strings, possibly. You can't possibly receive two strings and return one integer, so you need to fix it. So for now, I'm gonna keep it as t, means whatever I receive, I'm gonna return. Now notice with here, I'm gonna say, for example, cout sum of hello, then world, and see what it displays. Then I'm gonna see out again. I'm gonna say sum 1, 2, and L. Finally, I'm gonna see out sum 1.1, 2.2. And I'm gonna execute. And I'm gonna get an error. Cannot do 2 pointers, but they are not 2 pointers. Oh, I'm gonna tell it specifically because now it's treating it as const char array or pointer. So now if I tell it two strings, now it will work. For example, noticed earlier it told me when I clicked compile, it told me, hey, you're trying to cover a case that you can't overcome. So notice the same function, sum, at first it received two strings. So it replaced the t with a string, the t with a string, the t with a string. It returned the sum of two strings, hello world. On the next version, it received two integers. So now it returned an integer. Let me make it bigger. So on the first call, it returned a string. On the second call, it returned an int. On the third call, it returned a double. Because it received two floats, it returned a float. For example, I can tell it without a string. I can tell it I need you to return an int always. Always return an int, whether you receive an int or double. Notice it's gonna display 3, 3. So it received two integers, we replace t by integer, and then we return the sum as int. And then on the next call, it received two doubles, so it's gonna replace the t's with doubles. It will sum the two doubles, but it will return them as an integer, not as t. So I can control that. Also, I can control two types. I can say class T and then class T1. This T, I can give it the name. As a matter of fact, I give it whatever name I want. T1, T type 1. So I give a name. The standard is, or what's known is just T. T, T1, T2. So now I can tell it, you're gonna receive two types. If once you receive two types, replace the first one with the first one, replace the second one with the second one, and I need you, for example, to return the second data type. Meaning, if someone calls you with integer and double, return double. If someone call you with double then int, return an int. So I need you to return whatever the second parameter is. I can give it a third parameter. The third parameter is of type T, similar to the first parameter. So A input 3. Now I can say plus A, for example, input 3. So in this example, I'm telling it, hey template, overall, the total data types you're gonna receive are two data types. You're gonna either receive T or T1. Once you receive two data types, the first parameter is of the first data type. The second parameter is of the second data type. The third parameter is of the first data type. And I need you to return whatever the second data type is. The task or the responsibility is to sum them all. sum them together. The task can be whatever the logic or the business requirement is, but the syntax is as follows, whatever I just said. Hey function, you're gonna receive, in total, you're gonna receive 2 different data types, 3 inputs, but those 3 inputs are of 2 data types. For example, int double int float int, or double int double, or string double string. But for this logic, string doesn't work. So I'm not gonna mix double with string because of this line. This line cannot be mixed. So I'm gonna keep it double and integer and floats or chars. So let's now exercise this code. Hey sum, I need you to take integer, double, and then another integer. So once the compiler reaches this line, it's gonna say, oh, okay, I received 3 parameters. Then the first parameter is integer. The second parameter is double. The third parameter is whatever the first parameter is, so integer. If I tell it T1, 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 then it's gonna say, this can't work. It needs to be of the same data type. They all need to be of the same data type. No answer function timeline matches the argument type are double, double, double. Yeah, these are double. 1, 1, 1, 1, 1, 1. Oh, because I have this. Okay. Now it works. Okay. So let's go back to the example. T. So once the compiler reaches this code, it's gonna go and say, okay, I have 3 parameters. The first and third one should be the same because it's T, whatever the first data type is. And this parameter is T1, so it's gonna be the different parameter. And I need it to return as a second one. What is the second one? In this case, the second one is a double. So the function is gonna return double. Look, it's gonna reserve the decimal. If I tell it I need you to return T, means return the same whatever you receive as first and third. What are you receiving as first and third? You're receiving integer. So the fact that you're receiving integer on the first and third, and it's specified to be T and return T, then it's gonna return integer. See, it doesn't reserve the decimal. So I can control how many data types and what are the parameters. This is in general function templates. Let's go back to the book just so we make sure we didn't forget anything. So function template with multiple types. Here it is, multiple types. 2 types, I can have n amount of parameters, but all those parameters are of 2 data types. I can have 3 data types, T1, T2. Then we go to class templates. Class templates are the same, very similar. You're gonna have your own class. You're gonna say, it is my class. It's gonna say, okay, I'm gonna do them public for now. Public int, or let's do int x, int y. My recommendations are, and this is very important, anytime you're trying to write a template function, first type it the same with the same data type you're trying to call it with. For example, if you're trying to call the function with integers and doubles, then type the function as an integer first. Integer and double first. Once you test your function and make sure that it works, then convert it to a template. For example, here I'm returning int double int. First, this is how I write my function. I write it just so that's how I know traditionally. I write it with primitive data types. I test it. I make sure it works. Once I'm sure it works, then I convert it to a template. How do I convert this to a template? I type template class T class T1 because the total data types are 2. I only have integers and doubles. Then I substitute. So one data type, one of the data types is here, here, and here. So I can say T here, T here, T here. Then the second data type is here. Similar with classes. First, I type my class. For example, I have this class and it has a int sum that returns what? It returns x plus y. Now that I typed it, I can test it, do whatever I want. Once I'm ready, then I can convert it to a template. How do I convert it to a template? I go ahead and type template class. How many data types in total? I only have integer, so one data type, t. Then I substitute t everywhere I see an int. Now it became a template class. Now template classes has different initialization, meaning without it being a template, how do I create an instance? I create an instance by saying my class L instance. This is how I create an instance for normal classes. However, whenever it's a template, and I need to create an instance, I need to specify the data type. Basically, I need to tell it what is T. Okay, you're creating an instance, but this is a template class. What are you trying to substitute? What would you like X, Y, this function, da da da? What would you like T to be? I need to specify to the program or to the compiler what is T. And you do it by opening this bracket, angle bracket, specifying the data type, closing the bracket. Exactly just like how you create a vector. Why it's the exact same? If I was in class, I would ask this question. Why? Who can guess why these are the same? Because vector is a template class. Remember with vectors, you can create a vector and you can carry any data type of items. You can create a vector of double, vector of int, vector of your object, vector of structs, vector of float. The fact that you can create a vector with any data type, that means under the hood, it's a template class. Similar to my class right now, I can create my class to be int. I can create my class to be double. I can create my class to be string, etc. So I'll instance 1, I'll instance 2, I'll instance 3. Here I'm gonna say, for example, L instance 1 dot x equals 1. L instance 1 dot y equals 2. See out L instance 1 dot sum. So this version is for integers. Then I can have a version for double. Then I can have a version for strings. So semicolon, 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 string. This is hello. This is world. Oh, I don't want it to be constant char. I need to specify that it's a string. String. Now it should work. No suitable grammar function for accessing to int. It's a string. Oh, this is instance 3. This is instance 2. Now it will work. So look, F10. I'm creating an instance and I'm telling my compiler, hey, the data type is int. I can have 2 types. Then if I have 2 types, I pass 2 types. Anyway, for now, I have only 1. So I told it I need an instance from this template class and it's a type int. So now X is an int and Y is an int and sum returns an int. Instance 2 is double. Let's give it a double. So 1.1, 2.2. Run again. So the first instance of the type integer. The second instance is of type double. So now X is double, Y is double, and sum returns a double. 3.3. Then I told it I need an instance of the type string. So now X becomes a string, Y becomes a string, and sum returns a string. It's a class template. That's basically it. Exceptions and templates. Very simple, very straightforward. That's it for the chapter. So good luck with the homework. Good luck with the project. Let me know if you guys have any questions.